So today's lesson is going to be on multiplication and division of decimals, some with negatives, remember, because that's what we're working with this year. And so to begin today's lesson, I would like you guys to review what we did with fractions. And make sure you watch your signs. So if your answer is negative, make sure you make it negative. If it's supposed to be positive, make sure it's positive. Pause the video, complete these problems, and then come back to check your answers. You'll notice that for my first one was a negative, one was a positive, and so my answer should be a negative. And once I simplified, I ended up with negative 9/5. And for the second one, because they were both negatives, my answer should be a positive, and my answer turned out to be 6/7. Now today, because we're dividing decimals and multiplying them, we do need to recall long division, because that's one of the key pieces of this section. So if we have 734 divided by 2, we first need to figure out how to set up our problem. So we know with long division we have this like half a box. The first number always goes inside your box. I'm going to have 734 inside. The second number always goes on the outside. So now I have 734 divided by 2 set up and ready to go for long division. The next thing we ask ourselves is how many times can 2 go into 7? But it can't go over. 2 goes into 7 3 times without going over. We do 3 times 2, which makes 6. Then we go ahead and subtract these numbers. 7 minus 6 is 1. Our next step we have to do is to bring down our 3, and then we start the process all over. How many times can 2 go into 13 without going over? The answer is 6. 6 times 2 is 12. And when I minus these, I get 1. And then I have to go ahead and bring down the next number. My next number is 4, so now I have 14. Start over. How many times can 2 go into 14? The answer is 7. 7 times 2 is 14. When we subtract, I get 0. Because I ended with a 0, I'm all done. And my answer is the number sitting on top. So in this case, 734 divided by 2 is 367. We also are going to have to use longhand multiplication today. And so before we add in decimals and negatives, why don't we first review just normal multiplication longhand? Our problem that we have here is 54 times 13. So to set it up, I'm going to put 54 on top of my 13, and I'm going to multiply. When you set up problems like this, you always want to line up the right hand side, okay? So you're going to line up the right side. You should be able to draw a nice straight line on that right side. From there, we start multiplying. We always start with the number closest on the right. So I'm going to start with my 3. I have to multiply the 3 by my 4, which is 12. So I put down my 2 and carry a 1. Then I have to multiply 3 by 5, which is 15. And then I add the 1 that's on top. And I get 16. When I go and move on to the 1, because it's in the 10 spot, I have to add a 0. 10s have a 0, so I add the 0. And I do the multiplication all over. 1 times 4 is 4. I didn't have to carry anything, so ignore that. And 1 times 5 is 5. Once I multiplied all these numbers on the bottom with stuff on the top, I go ahead and add whatever values I came up with. 2 plus 0 is 2. 6 plus 4 is 10, so I put down my 0, carry my 1. And 1 plus 1 plus 5 is 7. So 54 times 13 is 702. We're going to use multiplication and division skills to solve our decimal and negative problems today. So our first problem today, we have negative 2.5 times positive 3.6. So first, just consider this. We have a negative and a positive. When we multiply them, we know our answer is going to be a negative of some kind. Then we have to go ahead and multiply. 2.5 times 3.6. 2.5 times 3.6. In this case, when you're multiplying decimals, they don't have to line up the dot. But in this one instance, they do. But it doesn't always happen like this. Then we go ahead and multiply like we did on the last slide. Start with my 6 and multiply. 6 times 5 is 30. Put down my 0, carry my 3. 6 times 2 is 12, plus 3 is 15. I can go ahead and cross that 3 out. For now, you have to ignore the decimals. Moving on to the 3, I'm going to add a 0. 3 times 5 is 15, carry my 1. 3 times 2 is 6, plus 1 is 7. Keep ignoring the decimals. I go ahead and add these together, 0, 10, and 9. At the very end, so now that we're at the end, this is when we go back and look at decimals. We want to know how many numbers were after the decimal in our original problem. I have one number here and one number here. I have a grand total of 2 numbers after my decimal. That means I need 2 numbers after my decimal, my answer. So a negative 2.5 times 3.6 equals a negative 9.00. You could also say it's simply negative 9. When we divide, we're going to use our long division skills. So our first problem is negative 0.18 divided by 0.03. So I'm going to go ahead and set up my division. First number goes in the box, 0.18, and we're going to divide by 0.03. You can go ahead and ignore the negatives until the end. Now with decimals and dividing, it's a little different. We have to make sure that the number on the outside has no decimals. So I have to take my decimal and I have to move it over 2 spots. You move it over all the way to the end. But because I'm moving this one 2 spots, I have to move this decimal 2 spots as well. So now, really, we can ignore the zeros. This problem is 3 on the outside and 18 on the inside. 18 divided by 3 is 6. 6 times 3 is 18. When I subtract, I have 0, so I know I did it right. And then I have to ask myself, should my answer be a negative or positive 6? Because one number is a negative, one is a positive, it's going to be a negative 6 for my final answer. If we look at this next problem, we have negative 816 divided by negative 2.72. So remember, when it looks like a fraction, it's really just dividing, okay? And now we know a negative divided by a negative is positive, so I'm actually going to just scribble out these negatives so they're not confusing me. And now I'm going to go ahead and set up my problem. 8.16 inside divided by 2.72. But remember, we have to move those decimals. So on the outside, I have to move it over 2 spots, which means I also have to move this inside one over 2 spots. So if I would rewrite this problem, I have 272 outside and 816 inside. Okay? Now from here, we just do long division. How many 272s go into 816? I'm going to be honest, I'm not sure, so let's figure it out. 272, that's kind of close to 300. And if I do 3 300s, that's going to be too much. I'm going to do 2. And I'm going to multiply. 2 times 2 is 4. 2 times 7 is 14. 2 times 2 is 4 plus 1 is 5. That seems kind of low. So let's add another 272, and let's see if we go over 816 or not. 4 plus 2 is 6. 11, 5, 6, 7, 8. 800. Ooh, look at that. 816. It was 3 of them. And 3 times 272 is 816. When I subtract, I get 0. Hi!
Hi.
So now that we've done the long division and we found our answer, we just have to recall, was it a positive or negative? We know it was a negative divided by negative, so we know our answer is going to be a positive, and it's 3, so we have a positive 3 for our final solution. This last slide is on your own, so use what we learned in the previous couple examples, apply it to these 3 problems, so pause the video, give these 3 a try, and then come back and check your solutions to make sure you have the work correct and the answers correct. So looking at our answers for number 1, we have a negative 9.18. The one underneath that is a positive 3.78. And the number 3 was definitely a challenge one, but it was definitely doable still, and it ended up being negative 1.25. If you were stuck on number 3, go ahead and just look up some other examples possibly, or come ask for help during your lunch or after school, before school, during class, so on and so forth. But it is a challenge. However, I know you guys can do it because you did it last year.